Hello and welcome to this video on beer color and SRM. Let's be clear, beer color and SRM, or the standard reference method, is a way of understanding not just the color of your beer, but why it matters, how it's measured, and why there is actually a standardized system, which is kind of important if you're looking at doing this not necessarily professionally, but possibly, say, considering putting your beer into competitions. There's a certain amount of science, history, and practicality to this that can be useful depending on how you're looking at doing this. So let's consider, what is beer color to start with? Mostly because beer color is kind of an obvious thing. It's the first thing you think of when you see beer. What color is it? Is it very pale? Is it very dark? And just about everything in between. Beer color is the visual hue of the beer, and it will range from practically white in the case of a wheat beer to what is verging on deepest of black. There are, of course, other colors like gold, amber, copper, brown, and even ruby. These are things you will notice when you, say, pour it out of your bottle into a glass or you start pouring a pint. It begins to set certain expectations, particularly with regards to flavor, style, and even some of the brewing processes that go into it. The color will come directly out of the ingredients used in brewing, primarily the malt, but also a certain degree from the adjuncts, hops, and even sometimes other additives such as fruits and spices. The color is a key part of many beers' identity and will help to distinguish them from others. For example, a light pilsner from a very dark stout. Amber beers are, unsurprisingly, amber-colored with a somewhat reddish coloration, hinting at the caramel flavors in it. Dark beers, such as a porter and stout, tend to be very dark brown to black and more associated with roasted chocolate and coffee-like flavors. So that's a very subjective and more qualitative description of it, but how do we measure and how do you standardize these colors to say, this is what it is? This is where the standard reference method, or SRM, comes into play. The standard reference method is a scientific system used to not just quantify the color of beer, but then categorize it. It provides a fairly reliable numerical scale to describe how light or dark a beer is. It allows brewers, judges, and general enthusiasts to communicate the color consistently. SRM is primarily used in North America and more endorsed by organizations located there, such as the American Society of Brewing Chemists. The SRM scale assigns a number to a beer's color based on how much light it absorbs at a specific wavelength. This is 430 nanometers, or the blue-violet range. Essentially, if it has the consistency of somebody who has no brain, such as R.F. Cray-Cray, and light goes straight through it, it obviously has less content. The higher the SRM value, the darker the beer. So for example, a low SRM of, say, 2 to 8 is a pale straw, whereas a medium is 8 to 20, which is typically a gold to amber or even copper color, and highs, 20 to 40 and even higher again, is for brown to black. To give you a bit of context, theoretically, a pure water should have an SRM of 0. That is, it is a completely transparent coloration, while the darkest beer should exceed 40. And this brings us to, how do you measure the SRM? Well, we'll start by breaking down the steps and the science behind it so that you can understand what's going on. SRM is based on spectrometry. That's a technique that measures how much light a liquid will absorb and how much of it gets bounced back to the receptor. In very simple terms, a sample of beer is placed into a small cuvette. This is, typically speaking, a small quartz square container similar to a test tube. The spectrophotometer shines light at this at the range of 430 nanometers, and some of this will go through the beer and some of it will not. The amount of light that is blocked is what is measured, as it is the difference between how much light is shone onto the beer and how much gets through the beer. This is what gives you your SRM value using a mathematical formula. It's 12.7 times the amount of light, that's the 430 nanometers, by the times D, where D is the dilution factor. A 12.7 here is a constant value that just helps to standardize the measurement for 1 centimeter path, which is typically the length of a cuvette. This gives a precise number that should correspond to the beer's color intensity. You might wonder though, why 430 nanometers? It's an odd choice, isn't it? Not exactly. It does correspond to the blue-violet wavelength of light, but it was chosen because it's sensitive to the compounds responsible for beer color. Mostly we're talking about malanoidins and caramelized sugars from malted barley. These are the primary color compounds, although not the only ones, but it does help considerably in measuring exactly what we're seeing. Because these compounds absorb the blue light more strongly, the darker beers, obviously with more of these compounds, would have a higher SRM by comparison to those with less of it. Practical measurements in a lab are, well, just this. The brewers will use a spectrophotometer for accuracy, but you can use a quick reference method. For example, you might use a color chart. This is, for all intents and purposes, something very similar to either a checklist for, say, chemical testing for water, or in other cases like for paint swabs. You can see that there is a specific color, and you simply hold your beer sample up against it and see what it matches to best. This will give you an approximate scale visually. Homebrewers will generally rely on a visual comparison, and sometimes software that will give you an estimate of the SRM based on the ingredients you have used. What influences the color? Well, we've already mentioned some of the major factors, and what's going to lead to the change in SRM is more than less going to be derived from the malt you use, which is the backbone of the beer you're making, and is the biggest factor. Barley is malted, and then that releases sugars. Those sugars are fermented and or sometimes not fermented. In the case of pale malts, typically speaking, it's not only more lightly kilned and therefore roasted, but more of those sugars are used, leading to a lower SRM value. The caramelized or crystal malts tend to be higher on the SRM scale, although they have a very wide range. Let's be clear about this, typically between 10 and 120, but because they're still also relatively highly fermented, a lot of that gets used up, and so you see a drop in the SRM value relative to what the, let's say, raw malt would otherwise have. And finally, roasted malts tend to be very high on the SRM scale, 200 to 500 plus, but again, because of fermentation, the use of those sugars, and the fermentation into ethanol and other flavor compounds, you see a dramatic drop down. This is why, generally speaking, the more roasted or caramelized the malt, the darker the beer and the higher the SRM value would be. But adjuncts can be another factor we need to consider. These can influence color notably. For example, unmalted grains such as wheat and oats tend to make the beer lighter, that is, they will lower the SRM considerably. Fruits and spices do something of the opposite, where they add coloration. For example, adding a cherry to lambic beers lead to a more reddish coloration. And then we have sugars and or syrups, such as molasses. These will darken the beer in turn, but this then has an effect on the SRM. We then need to look at the brewing process and particularly boiling time. The longer you boil your wort, typically speaking, the darker it will be. Now this is before fermentation, mind you, and that's because more of the content of the wort, the sugars, are caramelized. This will increase the SRM, but only slightly due to the nature of fermentation. The fermentation itself doesn't directly affect the SRM, but it will affect how much sugar is present and the clarity of the beer. And last we have the water chemistry. This can have a more subtle effect on it, but more likely to affect things like clarity and the perception of color, less so the SRM itself. Hops can contribute, but typically minimally, to color, as they're green and they are used in small quantities. The green coloration, because you're using a blue-violet wavelength, tends not to be affected as heavily. Some more heavily hopped beers, such as IPA, can add haze, and this haze can affect the perception of color, although thankfully not the SRM. But the SRM scale in practice does have a fairly, let's say, a reliable breakdown based on the style of beer, so you can get an idea about what it is you're drinking just based on the coloration. We won't go through this with you. You're more than capable of reading it yourselves, but here is the numbers and how they correspond to both color and beer style. And the reason we won't read it to you is because we assume you're an adult and more than capable of doing that yourself. If you want to do this yourself, you can visualize the SRM by simply taking a glass of beer and holding it up to the light. At an SRM of 2, it should almost be as clear as water, with a faint yellow tint. Basically, think of piss, or more accurately in this case Budweiser, although there's very little difference between the two. At an SRM of 15, it should be a much richer amber color, almost like an autumn leaf. And at an SRM of 40, it would be nearly pitch black, letting almost none of the light through, much like a emo child. There are other systems out there. Certainly speaking, SRM is not the only option. There are two related systems, the EBC, or European Brewing Convention, which is used obviously in Europe, and it is very similar to the SRM, it just uses a different formula and wavelength. It uses 430 nanometers and a different constant. If you were to take the SRM and try and convert it into the EBC or vice versa, you basically take your SRM and multiply it by 1.7. Or in the case of having the EBC, you divide by 1.7. This should give you an equivalent value roughly. So for example, if you have an SRM of 10, the EBC would be 19.7. As mentioned, this is basically the European convention and standard, and so you can, to an extent, let's say, compare the two reasonably easily. Finally, we have the Loverborn scale. This was before SRM, and brewers were using it fairly extensively in the 19th century. It involved comparing a beer to a coloured glass standard, and it was largely replaced by the SRM. It's still used to rate malt coloration, but because SRM is more precise and based on light absorption, not visual comparisons, it basically lost favour for the most part, and SRM and EBC became the reference. After all, if you have someone subjectively and very randomly say that this bit of glass looks like this colour, and someone else says, well no, it's this colour, it doesn't really work. The EBC and SRM give you a much more reliable result, and something that can be replicated. This is why many beer styles give expected SRM ranges. For example, this is one reason why, to be certified as a judge for beer, you generally speaking have a, let's say, criteria based on the SRM rather than Loverbond or similar. And of course, we get consistency. The brewers can use the SRM to ensure that between one batch of beer and the next, it's reasonably consistent. Or in the case of Budweiser, it's just water that's been near beer for a brief period of time. It also means that if you are making a certain style of beer, you'll know if something is not working as intended because the coloration is wrong. It allows you to meet consumer expectation on a commercial brewing level because, well, colour tells you something about the flavour that's going to come along. If it is a very dark looking beer, but it doesn't have a lot of heavy taste to it, it would indicate that something's not right, or that you've basically received dodgy beer. In other instances, a very light looking beer that has a very heavy taste is going to be like being smacked in the face with a wet fish. It's not going to be pleasant, and it's probably not what you expected. And of course, it affects recipe design, because if you're looking at doing this either as a homebrewer or even as a professional, the SRM will let you predict a beer's colour based on what you're putting into the fermentation. SRM is useful, but it has limitations. For example, it doesn't really capture hues that vary very much, nor does it necessarily measure the intensity of a given colour. So you're not measuring a specific coloration, you're just measuring how much colour there is in general. It might sound like the same thing, but it is an important distinction. This will tell you that there is a lot of colour, rather than this is the actual colour that you're seeing. Because of this, things like haze and clarity don't really affect it, but they can have a drastic effect on how much light is perceived to be getting through by the consumer. First of all, we need to look at that as a issue that complicates SRM, especially when we talk about perception and how subjective it can be. If you have a beer in, say, a glass bottle, the shape of the glass can affect it, and the light in which you're seeing it can affect what you think is the coloration, meaning that the SRM could be perfectly accurate, but you may not think that that's accurate based purely on the subjective assessment of it. And of course, we mentioned earlier that non-malt derived colours aren't accounted for very well with this. There are some fun facts about this we should mention. Before modern malting, beers were often darker due to the less precise kilning process, and it meant that the pale beers became very widespread in the 19th century. But as time progressed, things got darker, and darker, and darker, because you could more reliably kiln the malt. Guinness isn't the darkest beer in the world, despite being sort of towards the higher end of the middle of SRM ranges that are typical, with an SRM of about 25 to 30. Some imperial stouts tend to be much higher at 40 plus. Flavor and color aren't necessarily always linked together. For example, Schwartz beer is dark with a higher SRM, but it does have a very light, crisp flavor, which obviously is in contrast to what you would expect. And of course we have craft beer trends, which do lead to some, let's say, contradictions in what you see, experience, and how the SRM should have it working. For example, haze, additives, and so on can have a big effect on the appearance, but not the SRM. If you're a home brewer, and obviously brewing at home and don't have a spectrophotometer, you can estimate your SRM, either using the brewing software that you've chosen, and this allows you to calculate the SRM based on the grain bill and the quantities you used. The rough formula is the MCU, or the weight of malt, typically in pounds, times the Lovibond of the malt. You then divide this by the volume of wort, typically in gallons, although there are ways to convert this to proper civilized units. You then convert the MCU to SRM by taking the SRM equaling MCU times 0.2 for pale beer, and admittedly, to be blunt about this, the accuracy tapers off considerably for darker beer. Or you could simply use a visual comparison. Get yourself an SRM chart, or several known beers, and simply look at the appearance of that beer and the known SRM value, or obviously the chart. A beer color is arguably relatively complex, and as an aspect of brewing, it's almost entirely driven by ingredients and processes. The SRM is a standardized way to measure it, and it works fairly well overall. It works from everything from pale straw pilsners to almost jet black stout. The SRM will quantify color on a scale from 2 to 40 plus, and it does help brewers, drinkers, and more understand and characterize beer. The SRM is precise, but it is arguably not necessarily useful in all cases, all places, and in all circumstances. It is just one part of the beer brewing process, let's say. It will set expectations, but what you taste, as noted, can differ drastically from what you're expecting based on what it is, and the style of beer can be very deceptive in that respect. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.